Hello everyone and welcome back. So last time we turned an LED, which is the red LED on board this XIAO BLE board, and we turned it on with help of a button. And let me just run the program and show you how it worked. So basically we are checking if the button is pressed. If it is pressed, then we turn the red LED on, and if it's not pressed, then we turn the LED off, and we print messages as well so that we can see them on the screen. And as you can see right now, the button is not pressed, so we are seeing a constant stream of these messages being printed, and we are constantly engaging the CPU in setting the red LED high over and over and over again. And this is the problem that we want to fix, that we are waiting for the button to be pressed, but we don't want to waste CPU cycles unnecessarily. So this is what we are going to address today. So the program that we have is basically the same as before, at least until this loop. And what we are going to do, first of all, is use this wait for low method, which is an async method. And what this is going to do is it's going to hang this program at this line, so that it's not constantly pulling the CPU and checking if it has been pressed or not, because that is very inefficient. What this does is it basically uses interrupts at the back end, but all of that is abstracted away and given to us in this nice method. And so this is what we are going to use. So the program will sort of just sit at this point until the button is pressed, and if it is, then it will continue from this point. And then we want to wait for high. So first we wait for low, that is, we wait if the button is pressed, and if it is, then we turn on the LED and print this message, and then we wait for it to be released, and then the program starts executing from this line, and then we turn the LED off again. So let me show you how this one works. So as you saw before, when the loop started, it was constantly printing the messages here, which meant that the CPU was constantly engaged. But right now, the CPU has actually gone to sleep, because if the button is not pressed, there's nothing else to do. So I'm going to press the button, and you will see that message and LED also lights up, and when I let go, it goes off again. And then we are waiting at this line once more. So I think you should be able to appreciate that this is way more efficient than what we had last time. So and this is provided to us by Embassy. We are able to use this await keyword, and it's a really elegant solution and way more efficient than what we had last time. But I'm not sure if you can see it, but there is still a problem. So if this is all our program did, then it's perfectly fine. But let's say that we have another LED that we want to constantly run as a heartbeat. So let me bring that code to the program. So let's say we have this heartbeat LED, and it's connected to pin 2 on the microcontroller. And what we want to do is, regardless of if the button is pressed or not, because it's like a heartbeat, it needs to be sort of turning off and on constantly. So it doesn't need to depend on the state of the button. But we have a problem here, let me just run it again and show it to you. So the heartbeat LED needs to run constantly regardless of whether the button is pressed or not. But right now it's not doing that because our program basically hangs at this line and waits for the interrupt to fire. And that won't happen until we press this button. And once I do, you can see the red LED goes on as before, but the heartbeat LED now lights up. And now we are stuck at this point. Sorry, this already executed. Now we are back at this loop, and now we are stuck here again. So the heartbeat LED is not doing its thing. It needs to be blinking constantly, but because this await is blocking it, it cannot do that. So this is what we are going to fix in the next lesson using embassy tasks. So this is it for this one. If you liked this video, please give it a thumbs up, and I will see you in the next one.